Now I'm going to pass it off to Margaret. So I'm gonna stop sharing my screen, and if you could start sharing your screen, that'd be great. She's our first speaker, and she joined BPI in 2020 and manages the people and process behind BPI certifications. She brings over 2 decades of recycling and waste reduction experience, with her previous role being the executive director of the Virginia Recycling Association. Excited to have you join us here today, Margaret. Passing it off to you now.
I'm pleased to be here and welcome everyone. I'm going to start off by telling you about BPI certification, and then we'll talk a little bit about the details of lab testing, and Emily will finish things out with talking about field testing. So BPI has offered a certification program for commercial compostability for over 25 years. And we're really excited to announce the addition of a home compostability certification with the launch of our new commercial and home compostability program in December of this year. Currently, there are over 53,000 products certified for commercial compostability by BPI, and these are included on about 2,100 certificates that are held by over 900 companies. This slide gives you an idea of the types of products that BPI certifies, which fall into several main categories. Agricultural, which is things like plant pots and tags, growing medium, mulch films. Bags that could be carry-out bags, Ziploc bags, pastry bags, different types of bags, resins and ingredients that are used to make compostable materials and products, food packaging, food serviceware, and pet waste products. This graphic shows BPI's certification process. I'll quickly walk you through the basic process, which is the same for both commercial only and commercial and home certifications. And as we just saw, BPI certifies basic materials like resins, ingredients that are used to add specific properties to items like colorants or adhesives, and finished products. So before starting the certification process, an item must be eligible for certification. BPI's eligibility criteria are focused through the lens of compostable products as a means to an end to get desirable feedstocks to composters and to keep organics out of landfills. Therefore, the item must be associated with desirable organics like food scraps or yard trimmings that are collected for composting. We don't certify things like e-commerce mailers or toothbrushes or phone cases, even though they could technically be made compostable. They don't help divert desirable organics to composters. The item can't be a redesign of something that's a better fit for recycling. It's based on existing demand, infrastructure, and consumer awareness. And a water bottle is a great example of this. While it could be made of a compostable material, people are used to putting those in their recycling bin, and it would confuse composters, MRFs, and people when they finish drinking their water. Third, the item cannot require disassembly in order to be composted. A coffee pod is a great example here. All elements of a coffee pod must be compostable for it to be certified by BPI. The item itself must be labeled with the BPI certification mark unless the item has a category level exemption in place. And that could be through printing, embossing, etching. We don't dictate how the mark is placed on the item, just that it's there. And then finally, BPI was an industry leader in banning the intentional addition of PFAS in certified compostables. So once an item is determined to be eligible, we can start the certification process. To do this, a company fills out an application form that includes the formulation, listing every ingredient from every supplier used to make the item. They submit safety data sheets for each ingredient in that formulation. They sign a CDA with BPI since they'll be divulging trade secrets to us. And they also sign a statement of no intentionally added PFAS, saying that they are not intentionally adding PFAS to their compostable item. So our certification is guided by our certification schemes. We have one for our commercial only certification that's based on ASTM standards for compostability, and our new scheme for home compostability certification that's based on the French home compostability standard. These schemes are used to determine the tests required for BPI certification. The commercial scheme is available on our website for anyone to review, and the home scheme is available to BPI members currently and will be publicly available when we launch our home compostability certification program on December 1st. We contract with TÜV Rheinland and CERCTO, which is a third-party technical reviewer who determines the tests that are required for certification, based on the formulation of the product and the guidance in the standards and our test scheme. And so we have confidence in the test results. The tests conducted for compostability must be conducted by a lab like OWS, who's here presenting today, whose abilities have been verified through either ISO accreditation or an equivalency audit that allows them to be approved to conduct testing for BPI certification. We have a global network of over 35 labs who are approved to conduct commercial testing. I think we've got 18, 19 labs that are approved to conduct testing for our home certification. DINCERCO, the third party technical reviewer, verifies the attributes of the samples that were tested and reviews the test reports and data from the lab during the conformity assessment to determine if an item meets the technical requirements for certification. And kind of in parallel, while the technical review is taking place, BPI staff reviews layouts of product and packaging artwork to ensure that the use of the BPI certification mark meets the terms of our license agreement. The company enters into a licensing agreement with BPI that gives them the right and restrictions to use the BPI certification mark to market their certified item. And once items successfully complete the certification process, the company receives a certificate that lists the products that are covered by the certification by SKU. These products are also listed by SKU in our searchable online catalog. And this resource makes it really easy to verify if an item is certified and to find particular products that carry certification. Next, I'll give you a brief overview of the technical components behind BPI certification for both commercial and home certificates. Now, this is relevant because BPI requires home certified products to also be commercially certified for technical, legal, reputational, and mission-driven reasons. This means you can't certify a product for just home compostability. So ASTM D6400, which is a commercial certification standard, will continue to be the baseline certification for all BPI certified products and materials. So often when people think about compostability, they're only thinking about the testing requirements to meet the compostability standards. But for BPI certification, there are two sets of criteria that items must meet. On the left-hand side of the slide, you see the core criteria as outlined by the standards for compostability. And on the right-hand side, you see the additional requirements that BPI imposes on top of the standards. First, let's quickly walk through the testing requirements for the ASTM standards for commercial compostability. And I'll highlight this differences between commercial and home requirements in the next slide. So at a very high level, and again, Chris is going to go into much greater detail about this, but this will be kind of an introduction. So at a very high level, there are three general categories of tests that products must go through. The first is disintegration, and that looks at the physical and visual breakdown of the finished item. The ASTM standard requires 90% disintegration in 84 days, and the home compostability standard requires 90% in 180 days. Next is biodegradation, and that looks at the finished product and the ingredients and raw materials that are used to make that product to ensure that the carbon in the product and the ingredients can be completely used as food by the microorganisms in compost. This is measured as conversion into carbon dioxide, and the standard requires 90% conversion in 180 days for commercial compostability and 360 days for home. And finally, the third set of tests makes sure that composting the item won't have any harmful impacts on the compost itself or in the environment where that compost is applied. These tests include plant toxicity, where plants are grown from seed and compost made from the product, and compared with plants grown in the same compost that's made without adding the compostable product, and regulated metals tests and tests for fluorine to screen for PFAS. And then on the right-hand side are the additional requirements that BPI has for certification. Our eligibility requirements, our ban on intentionally added PFAS, and the requirement that certified products and their packaging bear the certification mark. Since the home certification is layered on top of the commercial certification, there are more similarities than differences between the two programs. And the differences are really centered around the different operating conditions and subsequent biological environments that are typically found in the two different composting environments. Commercial compost facilities typically run hot and fast under thermophilic conditions, while backyard bins are run at a smaller scale with less active management. So the composting process is typically slower and cooler under mesophilic conditions. So eligibility criteria between the two programs is identical, except for pet waste products are limited to commercial only certification, since backyard bins don't typically get hot enough to kill the pathogens in pet waste. The laboratory tests used to certify products for the two environments are also reflective of the varying conditions found in the different compost environments. Disintegration testing for commercial certification is conducted at high temperatures between 113 and 167 degrees Fahrenheit for a maximum of 84 days. And as I said, reflective of the conditions in a home compost bin, home certification disintegration testing is conducted at a much lower temperature between 73 and 80 degrees Fahrenheit for a much longer period of time, for up to 180 days. So this means that two different disintegration tests must be conducted for certification, one under commercial conditions and one under the home conditions. The differences are similar for biodegradation testing. For commercial testing, the test is run at 132 to 140 degrees Fahrenheit for 6 months, while for home, it's run between 73 and 80 degrees for up to 1 year. So another difference is with ecotoxicity testing. The French standard, and therefore BPI's program, since it's standards-based, requires ecotoxicity testing in compost that's generated by the ISO 16929 disintegration test method, whereas commercial testing allows the compost to be generated by either ISO disintegration test method, as long as the concentration of items at the start of testing with 2200 meet the requirements of 16929. This is because ISO 16929 includes specific methodology to address creating compost for ecotoxicity testing, while 2200 does not. BPI has incorporated this requirement, so our scheme is no less rigorous than the standard on which it's based. Finally, there's some differences in the allowable thresholds of regulated metals between the two certificates. The thresholds in the home standard and scheme are lower for arsenic, cadmium, chromium, molybdenum, that's such a difficult word to say, lead, nickel, selenium, and zinc. The thresholds for copper and fluorine are the same in both standards and schemes, and the commercial standards and schemes have lower thresholds for cobalt and mercury. So products being certified for commercial and home must meet the lower thresholds. So Chris, I'm going to hand things over to Chris, who will be covering the testing required for certification in detail in the next presentation.
Great. Thanks